Thank you so much. I come from the International Center for Theoretical Physics, where we study the expansion of time. So I think I'm in the right session. So my presentation is in line with what Wojciech presented earlier, and it's about one specific project that has to do with open hardware and the question that were posed. So the project has to do with low-cost weather stations, and they're based on a protocol which is called LoRaWAN, which allows these sensors to be connected where there's no GSM coverage, essentially. So it's sort of Wi-Fi for sensors, and it allows very long links so this weather station can be placed really in remote places. So we found some commercially available devices that are based on LoRaWAN. There's some pictures here. There's a main station where we're measuring temperature, pressure, humidity, and light. We have a rain sensor, and we have an anemometer. So this is how the devices look like. Looking at the parameters, I think the most interesting is the column on the right, which says meet WMO standards. So those are quite good weather station. In fact, they meet most of the WMO standards in terms of accuracy. And two pilots I'm presenting here. We have several others, some of them together with Kuhn. So the first one is in Ghana. So we work with the Met Office, local Met Office, and with the NREN, so the National Research and Educational Network, so the internet provider for universities. And the NREN hosted the gateways. We installed one gateway, one weather station at the Met Office headquarters, and the gateway is about 4 kilometers from the device. We publish some of the lessons learned in a white paper, just some pictures to highlight the fact that these weather stations are quite small, and they already have the solar panel and the battery in the device. So it's really handy to be installed. And as you see, they're really small in size as well. The data is hosted by the local organization and by ICTP. So we can host data in different sites. We can show the data in different ways, time series, or as the final user actually requires. Second pilot was about in Central Asia, Kyrgyzstan. So the focus there was to find out how we can manage openness and security, let's say on the technical side. There were many stakeholders. So the Met Office was one. There is a research organization, there are universities, there are internet society. They have a very strong local team, and we just published a paper on the results. So some pictures from this deployment as well. You see that the solar panel is much bigger. Of course, there's less sun in Kyrgyzstan than in Ghana, but the devices look exactly the same. The guy on the bottom left, he's installing some water level sensors on a local bridge. So there's a bit of hydrology sensors in this deployment as well. But again, quite similar to the Ghana case. The data here was hosted only locally, and they were interested in comparing results from the different sensors. So it's a bit different visualization compared to Ghana. But now talking about the openness. So if you look at the global architecture of this system, you have the weather station, you have this gateway, which is allowing the weather station to connect to the internet. You have some servers. So most of it is open. So LoRaWAN is an open protocol, so you can add weather station from different vendors. The way we send data from the gateway to the servers is based on MQTT, which is an open format. We visualize data using Grafana or Fingerboard, which again is open. But we still have the gateway and the weather station. So what about the gateway? So what are the main features? It has to be low power. It has to support different communication protocols, Wi-Fi, Ethernet, or SIM. Needs to have data buffering so that we can keep the data if there is no connectivity for some reason. It has to support VPN, and the price is roughly 600 euro. So the question, which I would like to pose, is it worth developing an open gateway? Following to what Wojciech was saying, can we scale it up? Can we install hundreds of them, or just build hundreds of them? And what would be the cost? I would say, again, the hardware inside these devices is maybe 100 to 200 euros. So it would definitely be lower cost, but it's really hard to scale it up. And going to the weather station, it's kind of similar. So it has to be low power, it has to support LoRaWAN, has to, have a solar, panel. And the cost of this commercial solution is about 1,000 euro. So it's low cost, but not extremely low cost. And again, can we scale up a do-it-yourself solution? But most important one is the final one. How can you ensure that it provides accurate measurements over time if it is assembled do-it-yourself? So would Met offices be happy to use this kind of open weather station solution? And in fact, in all these projects, we had to kind of balance in a way the cost, the upgradability. The comment about control in the previous question was really good. Who has control on these devices? Do we know exactly what's happening? Is the firmware open or not? But on the other hand, we have scalability and consistency and accuracy. So it's open questions, like open solution, but it's really open question that I think the community should kind of tackle in some way. And that is all from my side. Thank you very much.